Join the course. I'm very happy to kind of see. Yeah, it's there. So yeah, I'm very happy to see all of you actually having some final projects to show today. And yeah, let's just get started. And yeah, before you begin, just to use the microphone, put it somewhere close. And start maybe like with introducing yourself, your name, your department, and let's go.
Does it start?
Yes.
Okay, hello everyone. My name is Yiping, and I'm an architecture student. So I'm interested in like some architecture models or the concept in architect stage. So in this course, my first concept is thinking about the dynamic architecture models. First is what is the dynamic architecture models, and as at the first class I present 3 types. I will present it again. The first one is called 3D display. It's just like this. It is like a screen on the surface of the buildings to present some like pictures or images. Okay, this is the first type. The second type is like dynamic models. In like use electronics, some parts of the build models can move. The third type is what I choose to do. My project is dynamic facade. Also, there is a video to present what it was like. Okay. This is what is my project like. This axometric showing how it's like. We can see the models later, and this show how the whole system. The right picture shows the gill system. I think the gill system is the most important part in my project. To rotate 2 types. It's divided into inner ring and outer rings. So the first week, this is the first try. In this stage, I'm also thinking about they have double layout. One is for the outer ring and one is for the inner ring, and it is a single drive. The gears on the motors will drive the outer ring, and the inner ring will drive by the gears on the outer rings. But there have some problems with these tries because the speed of different ring is different. So I didn't want to do that. I want to have them keep the same speed. So the next 2 weeks I try the double drive. You can see that it has 2 levels. I write 6 important statistics of it. One is number of teeth. Through try we can find that we cannot just change the size of the gears. We need to define the number of the teeth to define the size of the gears. The second number is the pitch diameter. You can see from, I think is this side called these lines, the red lines called pitch diameter. This is the most important things I think, because it design the gears can work together. The third status is the major diameter. It designs the size of the gears. And another 2 is the minor diameter. You can see that is these red lines, and another one is bore diameter. It is in the corners. It decides the columns of the gears. In this stage, the gears can work together, but the problem is that the gears cannot remove the belt. So in the final stage, I try to fit the belt the gears to fit the belt. And in this stage, there are also three important statistics. One is called coefficient addendum. This will define the height of the teeth. The second statistic is coefficient clearance. It will define the scale of the top and the gap. The final one is backlash. It also defines the distance of the gap of the gears. Change these three statistics, you will fit the belt. Let the gears. And also you can see it will divide into two levels. One is outer ring and one is the inner ring. This is my final models. Yeah, yeah, you can see. Finally, it doesn't work very well, but we can first see how it works. It finally become a roof rotate program. Yeah.
It's an evolving.
It's a completely new type of art.
It will become a landmark.
Okay. Analyze the reasons for fail. The first, maybe the teeth is too small because I need to fit the belt, I said before. But the teeth is too small finally to fit the belt. They cannot drive each other. The second problem maybe is oblique laser cut the gear not very well, so they can also drive each other finally. So potential solution to solve the problems. The first, maybe I said before, I have two layout. Maybe I can change it to four layout. One layout is for the drive layout. They can drive each other, and another layout is to drive the belt, dividing into two layouts. Another one, a solution may be to the thinner pieces of the gears. Because the thinner piece and the laser will cut it better. The final solution may be a stronger driving force. I think the motors may be not strong enough to drive two layers. Maybe stronger in the future. Maybe we can drive. Okay, thank you everyone.
Very nice.
Okay. Let's see the models finally.
Yeah, it would be interesting to disassemble it also a little bit. So maybe you could stop it and take the roof off, and so that
Take the roof
see what's inside. Just stop the motor. Yeah. Okay. The core of the system. All right.
All right.
So thank you.
Thank you.
I will try one more time to maybe who goes next? You go next. Okay. Yes.
Hi everyone, my name is Yu, and I am from Department of Architecture, and my project is floating skateboard. But now it changed. It is portable skateboard because it's due to the time limit of time. So the floated part cannot be experimented at this course. And this is my idea at first. I want to make a skateboard that can be floated, and after floated, that it can be put on the back, and I think it's very convenient. So I will show the process of my work. At the first week, I designed the shape of the deck. And this is the dimension of the deck and the 3D model. And At first, I think the skateboard is very easy. It is just like I cut a board and then I put 4 wheels on it that I can use it. But it is not as easy as I imagine. It is in the process of making a skateboard. I found I encountered many difficulties. And so the first difficulty is that the board actually is bended in 2 directions. This shows the slide shows the crosswise cutaway wheel and the lengthwise cutaway wheel of the skateboard. And about the curve of the board, at first I think maybe I can mill the whole part of the deck, use the CNC machine. But after I googled how to make a skateboard, I found that the skateboard is not just a whole plywood. It is actually made up of like 5 to 7 layers of plywood. So after that, I think maybe I can mill each part of the plywood, but it wastes too many materials. So after that, we try to use the mold to curl the plywood. So the next step is try to design the plywood. But this shows the second try of the models. The first try is just design the two long side of the molds, and it just curls the plywood in one direction. So this is the first experiment. It just curl. It just curl in this way.
No, it's fine. So I think that you can see the silhouette really nicely. So I put it here.
Okay.
Like so. Floating in the air, like tiny. Okay.
So after the first experiment, I know that the plywood can be bended in this way. So in the second experiment, I tried to make the mold to make the to allow the plywood to bend in 2 directions, and the slide shows the process of how to use the mold to make the plywood bended. And about the material I used to make the skateboard. About the deck part, I use 2mm plywood and use a CNC machine to cut the shape of the deck. And about the mold part, I use a 16mm MDF and also use a CNC machine to make the mold. And the slide, the left side of the slide shows the first experiment of the bended process, and the right side shows the second experiment. And I'm really happy that it works. Yeah, this is after 48 hours the blended deck produced. And after the deck part, the next step is to try to put on the trunks. So we make the pockets for trunks and also brush wood oil. And this is the final work. The two sides, yeah. And also use the stickers to beautify the skateboard. And this is a really happy work. In the process of making a skateboard, I learned how to use a new software, Fusion 360, and I also learned how to use a CNC machine. And in the process of making a skateboard, there are many difficulties, and such as I made a mistake in the modeling. So the modeling, but we try to solve the problem, and what I think is not makes me unhappy is that due to the limit of the time, it is not a floating skateboard. It's not what I want to do at first, but I'm pleased with this skateboard. And another I am not happy is that it can't keep balance, and in the process of trying this skateboard, I falling down. Yeah, the sorry, final project.
Okay, great.
Thank you.
Yeah, thing. All right, so.
Hello everyone, this is Yuyang, and I'm an architectural student. In this course, what I want to do is architectural analysis instrument. I first want to do the instrument to analyze the light, but now I think it can also analyze the human view of the architecture. And after 1 week to listen to the lecture, the week 2, I first built a model like this. I use 2 racks to control the instrument part for the light or the micro camera. And I meet a problem that the 2 racks is not necessary. Maybe 1 rack is enough. And what I designed, there is no space to place the gears and the motor. Nope. And later I generate another building that I first put the motor here and use 3 gears to connect the motor with the rack here. It seems like this, and the lamp is placed at here. But the problem is that the rack and the gears should be designed more detailed. You see, it's only a circle, but not a gear. And the connection of gears is a little bit complex. That if it is not so,
A little bit complex, yeah.
if I can't design it very accurate, that I cannot use the motor to move the whole part. Yeah, at week 3, I first make a test of the gears and the racks. First, I use FreeCAD to generate a gear and a rack. I first make a straight rack and a flat gear, and I test it with laser cutting, and it works. It works so well. And the next step, I try to bend the rack with Rhino and Grasshopper. First, I bend the rack with the arc curve, and then I float the flat gear to a ball, which the radius is same like the arc curve above. And I test it with 3D printer, and it's lucky it works well too. And then I made my final model like this. It contains two motor retainers to fix the motor on the racks and a motor here, which we bought from the store, and and the and the, and the most important part of my design, the gear and the racks here, and the base and supports which use the laser cutting. Yeah, and the 3D printer part and the laser cutting part. Yeah, you can see the base, the gear, motor, racks, basement, and the electronic works. Yeah, and this is the whole part of the model, and I will show you. It's here. But yeah, wait, I have something to. Yeah, but I have some summary that the 3D printers have tolerance and the tiny gaps should be kept between the components. And at first I didn't build some tiny gaps so the racks cannot go through. The rack cannot go through the instrument. And the electronic works are far more complex than I thought. I cannot work well, and I do not know how to edit the codes. And at last, the motor is much heavier than expected, and its power cannot be move itself along the racks. It goes more than along its gravity, but not from the cover. So future, maybe I will attach lamps or micro cameras to abandon the design, and also maybe a button to control how to move.
Yeah, one thing that I remember we discussed is that so we should dive more into the specifications of the motor. So meaning that each of these have the the power rating, no, not a power rating, but more like how much weight they can carry. Like, and as you stated, it's in this case the motor, it's not being able to lift its own weight. But this you are going to see.
Yeah, it can go down, but then it stops. It cannot go back. When I move it to another.
But the idea is like this: it basically moves the light around, like so.
Yes.
And it,
but it cannot. Oh no.
It should move like this. If you help it a little bit, see, like a light simulator.
Yeah, so. And we can change the angle of this.
We don't need more.
Okay, that's all. Thank you.
Yeah, now it's there. So maybe it's the splitter that was malfunctioning.
But we have these red lines, but I think
and then the microphone.
Yes. It shows the colors a bit differently.
That's fine. I mean, it's gonna be even more different over here.
Yeah. Okay.
Okay, hello everybody, I am Neha and student in the media lab at Aalto.
And I joined this course a bit late, but it has been quite a big learning process for me, so that I would rather talk about the process of doing things and the way I have not been used to, and while talking about that, I'll talk about the project that I have worked on. So this is like a little urban precinct in a city that I have grown up in, which is the basis of my research, where I have been collecting data about communities and how communities live together in an urban precinct, and how an architectural place comes about and what is the meaning of it. And then I have been studying this place in many different ways, and one of it that I did in this beginning of this year, which was about collecting folklore in that place, which is just a little addition which was not planned, but I found these things out, and then I was mapping these folklore stories or narratives in GIS, where the guardian spirits in this place take a walk in the night and sort of protect the place. And it became quite interesting aspect to define and understand how communities connect to their own place, or how they perceive it, and how a place evolves. So I thought for this course I would just start with a basic 2D model in which there would be an interactivity involved, and that a user can sort of select certain options of narrators, and an audio playback would happen, and then the location of the saints in the precinct would be highlighted, and then you would see and understand how this actually happens. Now these narrations are in the local language, which I haven't actually solved the issue, and so to begin with, I decided that in this course I can just utilize all that was taught and sort of learn those things. So obviously there is this huge gap between what I am studying, what I represent as an urban precinct, the methods that I have been using as representation, the data that is collected, and now you go into the machine fabrication learning environment, which you then sort of, I have found myself struggle with what I bring from those kind of things into this kind of environment. And then there has been lot of there's a huge gap that I could not understand and perceive in the beginning, and that's why a lot of failures happened afterwards. Like that yesterday Yiping was asking me, why am I having this footprints of the building which are really hatched, but that is coming from the urban design methods of representing footprints. So then, but then when you do the machine fabrication and start to sort of use these machines, then that gap has to somehow be breached or understood better. So then the first iteration that I did was on an acrylic sheet, but somehow I was always thinking that I should stick to this idea, and Chris also advised that I should stick to this idea of prototype and not really aiming at making a finished model, because I am supposed to build a 3D model, and I thought this would be a simple prototype that I work with electronics, that I work with machines, and then I try to understand what goes wrong. So then the idea of acrylic got stuck in my mind since beginning, and then I thought I would use a transparent acrylic. So the first iteration was working on a CNC machine where there was an engraving of multi-layered engraving, and then a lot of particles got stuck to the drill, and then the engraving got spoiled a bit. But I think it was not the problem of the drill or the machine. I think I have conceived it completely wrong, in the sense that it was a very dense drawing and not simplified at all. I was just bringing these DXF layers from GIS and not working them as at a vector level, which should have happened for a machine to understand. And this is where I think the biggest learning has happened, because I should have simplified the drawing, reduced the number of lines, made them more clear, and that I completely did not work on. But yeah, so that sort of failed. And then the second, I still continued with this idea of acrylic, but then I thought that we can split the engraving in 3 sheets so that the drill is not spoiled and we can get a better result. And simultaneously I was working on the electronics, so I thought that I would I worked on used a Raspberry Pi and then the Python script which Chris wrote for me, all of it. And but then I actually, while doing that, because that is not in the slide, I just want to quickly mention that because of that I actually learned the Python scripts. Then because you mentioned about Audacity, then I learned it over the last weekend, re-edited the audios. So this has been kind of a process of learning multiple things at the same time. So then obviously my focus on the drawing itself was less until on Sunday this weekend I really decided that that is the issue I really have to solve. So then here what happened was everything actually worked well, and 2 sheets of it were done on the laser cutter and 1 of it was still engraved on the CNC machine. But when you put it all together, the refinement of the drawing does not come about, and the whole purpose of how I wanted the engraving to be seen could not be seen at all. So it didn't just match because the laser cutter's accuracy did not match the drill's accuracy, so the drawings were of different accuracy. And in the third iteration was, which is what I have now worked on and quite satisfied with, is that I thought I should reduce the whole drawing scale to 1/4 so that the building size becomes bigger, and I reworked on the vectors from Inkscape to Illustrator, and then hence I learned Illustrator a bit, but I didn't learn all softwares at all. They were just, I just am sort of introduced to them. And then this was today when we tried some samples, so that was also another learning process of how engraving should be done, and that is now done. And then the interactivity of electronics is something that I have been parallelly working on, where I would print some PCBs and with LEDs and all, make this all happen in the end, which has not happened so far. But the whole point of this course was, I mean, it has given me something which is I cannot compare to what I have learned before in such a short period of time. So the first and most important thing was the understanding of how digital fabrication works at all in the first place, because my mindset was where I talk to people and then they work it all at their end, and then you are always on this communication level which is very moldable, like you can change this communication between people, and then oh no, and then the other guy is putting all his thought process and thinking to make it correct. Whereas in digital fabrication you have to first of all understand how the machine works and how what goes into it, and the process is completely different because it has to be extremely careful since the beginning when you sort of conceptualize the project until you actually cut things on the machine. So it's a very process of extreme presence of mind, which I think my research has made me so absent-minded of such things where you just go into the field and take some interviews. And this is an extremely smart process of working which I would have to get used to. And then I learned a couple of softwares which was amazing. I wouldn't say I've learned them, but at least got introduced to, and then the machines which I haven't really used all to their fullest, but then it is quite a lot in such a short of period of time. And then thank you to Chris for allowing me to be part of the course. I'm sure if we were more in numbers, then you wouldn't have given us so much of attention that we got. And
which is nice. You know,
yes.
I always think like somewhere in between 5 to 10 students. It's I think 10 students is a maximum
Yes.
for this space anyway. But
Yes.
so you were lucky that
Yeah.
people from the media lab didn't join.
Yes, and so that's it. But can I show these things? And so I don't know
Oh yeah, so actually if you show it as a silhouette, like in front of the projector light, then
Okay.
so it works best, I guess.
Okay, so this was the first one, and where we did all of the process on the CNC machine, and like that, and yes.
Yeah, the reflection. Look at that.
Okay. And so it actually looks quite pretty, and I still like this the best. And then these are the two different things. This is from the CNC machine, engraving and the laser cutter. So I wanted to actually sort of layer them together and have an effect which I sort of imagined would come, but I think it only didn't come because the drawing is not clean and clear and not well thought of. Otherwise I think this process would have been still successful. And then this is the last one that we printed today. It looks so nice like that. And so this is actually the quarter of the wall area, and then everything starts to become clear, and then I would have these LEDs and an interactive buttons which needs to be worked on. Thank you.
Yeah.
Oh, I should have.
You're just doing it, so it's. I think you're doing pretty good with this, at least from my perspective.
Good. Okay, so that's it. So let's clean up and let's go have a beer.